In this video, I'm going to go over how to create the tool paths on the lathe to make this part. This is a bearing plug. It's designed to be pressed into aluminum plate before we powder coat it to protect the bearing surface from being coated with powder. It also protects the surface of the flange of the bearing as well. So this space here and here would be protected from powder, so that when we powder coat it, after it's done, we can remove the plug and put the bearing in. This is made from PTFE or Teflon, and it's pretty easy to machine. The Teflon has a high melting point, so it doesn't melt in the oven at 400 degrees. Also, the powder coating doesn't stick to it, and so it can be reused multiple times. The stock material is 1 3/8 inch in diameter. I just buy a long tube of it, and we just make a bunch of these on the CNC lathe held in a 3-jaw chuck. So to get started, what we're going to do is go to setup and click machine and tell it that we're using a lathe here. So we're going to use a generic lathe. And this side here is going to be the front, and so I'm going to just flip the Z-axis. I can click here or flip Z-axis there, either one. So the positive Z, that's the axis, the spindle axis, and then the X-axis is the direction that the tool comes in. There's no Y-axis movement on the lathe. So the next thing that I'm going to do is just go to the stock and change the diameter of the stock to 1.375. And what we typically do is face the part before we start machining and set that as Z0. So I'm going to set Z0 to the surface of the part, not to the surface of the stock. So I can go to offset from the front and just make sure I have a 0 offset. So my Z or the origin should be at the surface of the part. You can kind of see the stock there. Then hitting OK. The first thing we're going to do is a profile roughing, and I'm going to choose a tool from the Tormach lathe tools. Tool number 1 is a turning facing tool that will work, and I'm just going to hit select. And basically we can go through the steps here. There's not much that we have to change. Okay, it has the model front is the front face that we want to go to, and the model back is the back face we want to go to, and that's, we're going to basically move the tool through this distance. You can add extra distance and things like that, but we don't need to, but here is where you could do that. The clearance, that's where the tool moves from, is basically 0.4 inches from the outermost part, which is pretty generous. If you want to speed things up, you can reduce that number a little bit so the tool doesn't have to move from such a high clearance height, but you can adjust that there. The number of passes, basically we don't want to cut off too much material. By default, it looks like they have just under 50 thousandths in per pass on the roughing. For this soft material, that's fine. We don't need to change anything there. And then at this tab, we don't need to do anything with. There is something I want to talk about on the first tab, and that's the default speeds and feeds. So this is held in a 3-jaw chuck, and the CNC lathe has a top spindle speed of 5,000 RPM. But they do not recommend that you run the 3-jaw chuck at that rate, and so I'm going to change that to just 2,000 revolutions per minute. Now the surface speed, you can think of that as the tangential speed of the part relative, or the tool relative to the part, and we're going to just leave that at 200 feet per minute, and that will be fine. We'll talk more about feeds and speeds in a lesson in class. But for now, the default setting there is fine. So now hitting OK, we can kind of see what the tool is going to do. We're just going to go through several steps and cut the material down. One thing I skipped over is the stock to leave. It does leave a little bit of stock, 4/1000ths in the X and the Z, that we'll clean up with a finishing pass. So I'm going to go right click, create derived operation, go to turning, and go to profile finishing. We're going to use the same tool but just do a finishing pass. We can slow down the speed a little bit. Again, we're just playing with numbers here just to see that we can change this. The default would be fine, but I'm just going to slow it down a little bit. And since this is going to go into a bearing hole, I'm going to actually slow down the feed rate. So the feed per revolution, that's how far the tool moves in the Z direction per revolution of the part. And if for a finer finish, you can make that smaller, but it will take longer to go, longer to machine the part. But we want a nice finish to make sure it fits in that bearing hole. So I'm just going to slow that down a little bit. The other thing I'm going to do is go to this tab here and add a spring pass. If you remember, a spring pass just repeats that path and ensures that we get the right diameter due to any tool or part deflection. So I'm just going to hit OK, and you kind of see what we're left with here. The next thing I'm going to do is just do a simulate, and I'm going to show the stock, and I'm going to show you what the part looks like here. Notice the cutter has a curved end, and so what that does is it leaves this curved portion here due to the part, and we actually get a little warning because of that. But what we want to do is make sure that this is actually cut away and that we don't have that, because we want this surface here to fit flat against the aluminum when we press this into the bearing hole. And so we have an actual grooving tool that can do that for us. And so basically, under turning, I'm going to go to single groove. I'm going to choose our grooving tool, same tool that we use to do retaining rings or snap rings, this 40/1000ths grooving tool. I'm going to select that. The default speeds are fine. I set those when I set up the tool, so it doesn't spin that fast at 1000 RPM, and the feed rate is reasonable. This is actually set for aluminum, and this plastic's a lot softer, so it's we don't need to do any changes there. But we do need to select the geometry. We're going to go right there is where we want to groove, but we want to offset from the front. You kind of see that the tool come down here. And the last thing I do is I set a dwell. I like to have the tool sit at least a second or two at the bottom to make sure that we go through several revolutions before the tool comes back, and then we can hit OK. And you can see that the tool come in, go down, and cut that away. One thing we can do just to save a little bit of time is on the clearance, we can reduce the clearance height so that the tool doesn't have to come from such a high distance away and then start feeding in. And we can reduce that even further if we wanted, but that will save a little bit of time on machining. So now when we go to simulate, let's take a look at what we have. Let's speed that up a little bit. So we're doing our roughing, then we go to the finishing, which has the spring pass, and then we come in with the grooving tool and clean up that edge. Final thing that we need to do is cut this off, and so we're going to use the parting tool. So the next operation is a part, and it already knows that the part should be at the back of the piece. We're not going to use the grooving tool to do this. We have a dedicated parting tool that is right can't remember the number, it's right here, this tool right here, the parting tool. Going to hit select there. Again, the maximum spindle speed I'm going to set at 2000 RPM. We can also slow down the surface speed in feet per minute. But that's about all that we need to do there. Just hitting OK. You can see that we come in and part this off. So finally, if we do a simulation, I'll speed it up a little bit. You can see that we come through, we do the grooving tool, and then we part the tool off, or part the piece off, and we're done.